Okay, so this is Professor Alison Lew with Carolina University for Public Health 100, Human Nutrition, Wellness, and Safety, and this is Lecture E. So first we're going to talk about some applied nutritional concepts before we get into energy balance. These are the relevant portions of the textbook with links. And first let's talk about describing nutrient needs, because that's most of what this lecture is going to be about, and then trying to figure out how we balance energy using that information and other information. So there are various terms that are used to describe nutrient needs. These terms describe how much of nutrients humans need and fall under the category of dietary reference intakes, or DRIs. Many scientific organizations actually contribute to the development of DRIs, and they're global too. There's multiple scientific organizations involved. So dietary reference intakes, here is a list of 4 reference values that are under the umbrella term of DRI. So think of DRI as this umbrella here. And then these 4 reference values fall underneath that. They're all DRIs, but they're individual ones. So first we have the estimated average requirements, or EAR. We have the recommended dietary allowances, or RDA. We have the adequate intakes, or AI. And we have the tolerable upper intake levels, or UL. Oops, too far. All right, so let's take sodium for an example. So we have different age groups over here. We have the adequate intake listed, and then we have the tolerable upper intake level listed if it's known. So for infants, you've got a value there. Let's take adults, for example. 19 to 50 years of age, their adequate intake for sodium is 1,500 milligrams. And we've talked about before that most people are getting way more than that, but that's the adequate intake. The tolerable upper intake level is 2,300. Now you can look up here to infants and you see ND. That means not determined. And a lot of the tolerable upper intake levels haven't been determined. So the estimated average requirement, or ERA, are the nutrient intakes that are estimated to meet the needs of 50% of the healthy individuals in a specific gender and life stage group. That's average. So think about average when you think of this one. So that'll help you remember that it's the intakes that are estimated to meet the needs of 50% of healthy individuals. All right, what about the recommended dietary allowances? That's the RDA. Those are levels of intake of essential nutrients that, on the basis of scientific knowledge, are judged by the Food and Nutritional Board to be adequate to meet the known nutrient needs of almost all healthy people. And this is an article about RDAs. If you want more information, want to be challenged a little bit, you can look at that article. What about adequate intake? An RDA for a nutrient cannot be established unless the scientific community has significant amounts of information about the human need for that nutrient. Some nutrients don't have an RDA at this time, and instead of an RDA, they have an AI, which is an adequate intake. Adequate intake is based on the amount that appears to be sufficient for human health because there's really not evidence of a deficiency. And so because of that, they establish an AI instead of an RDA. So adequate intake is the level of a nutrient intake that should be used as a goal when no RDA exists. This value is an approximation of the nutrient intake that sustains health. Okay, so let's look at the example of chromium, which has no RDA. Chromium does have an AI though, and it has that AI because there's not enough information out there to establish an RDA in the scientific community, but they can already go ahead and establish an AI as a guideline to help individuals and clinicians know what would be adequate based on what we know right now. Then we have the tolerable upper intake levels, or UL. That's the maximum daily nutrient intake levels that are likely to pose health threats to almost all individuals in a given gender and life stage. So these are the upper limit. Think of it as the upper limit, okay? So the maximum chronic daily intake level of a nutrient that is unlikely to cause adverse health effects in almost all people in a specific life stage would be that tolerable upper intake level. And here we see individuals of different ages. These look like, they may be in the same family, but different ages of people. And it does vary based on things like your age, because stages of life, developmental stages, age makes a big difference in what's needed, and then also what the tolerable upper intake level would be. We physiologically function differently at different ages and life stages. So the estimated energy requirement, or EER, is the estimate of the energy or calorie. That's sometimes abbreviated kcal when we talk about nutrition. When we're talking about those kind of calories, they'll say kcal. Intake needed to match the energy use for an average person in a specific life stage. So let's go back to calories for a minute. When we're estimating energy, the scientific word calorie has a slightly different meaning than the word for calorie we use in nutrition. And it's a matter of scale. So when we're talking about nutrition class and we talk about calories, they're really kcals, okay? So not many people write kcal very much. The general public doesn't know the word kcal or know what that means. So we just use calories. But, know that there is a scientific word for calorie that is used in general science. And then when we talk about human beings in nutrition class, because we talk about human beings and what they eat and their calories all the time, we kind of colloquially refer to that as calories, but it's kcalories or kcals because it's kilocalories. Okay, so chronic disease risk reduction intake. The first DRI that are disease specific and target risk reduction for a chronic disease is actually sodium. But this chronic disease risk reduction intake is a newer measure. And what we're trying to do is help people take better care of themselves and reduce the risk of chronic diseases that often cause disability as people get older, especially, and can cause death. So this is newer. And the CDRR has been established for sodium because of its relationship with the cardiac disease processes, but it hasn't been established for others at this point. Okay, so let's look at a food label for a moment and look at the daily value, or DV. That's over here on this side of the food label, okay? And it's used on food labels. Males and females 4 years old or older can benefit from this information. Based on a 2,000 kcal diet, okay? So that's what the percentage is based on. If this person was supposed to eat 2,000 calories a day, and remember that everybody's is going to vary based on a lot of things, then this is what they would need to get. And the reason they choose 2,000 kcals diet is because it's a commonly recommended amount of kcals in a daily diet. But there are people that need less and there are people that need more, and they would have to remember that as they're looking at the daily value, or not use it at all and look at other information like looking at their individual nutritional requirements instead of looking at these percentages. But the percentages help a lot of people. They allow for comparison by consumers. So consumers can take these percentages and compare from one product to another to see how it would meet their needs. So the acceptable macronutrient distribution range, or AMDR, is yet another term. The acceptable macronutrient distribution range is the calculated range of how much energy from carbohydrates, fats, and protein is recommended for a healthy diet, adequate of the essential nutrients, and is associated with the reduced risk of chronic disease. So if you wanted to prevent chronic disease, then this would be a way to see how you're doing with that. This is a newer term too. So the AMDR for the various age groups is listed here as examples, and you see it has protein, carbohydrate, and fat. Okay, so when we talked about fat, remember, we talked about what was recommended, and for adults, here's that recommended range we talked about. So with that, we were trying to prevent things like heart disease, like coronary artery disease and stroke, right? And we talked about that. The amount of fat that should be in your diet, if you want to prevent these things, should be a healthy amount, and this is it. And so this AMDR helps establish that. So let's go back to our nutritional facts label. And here you can see the different parts have been labeled to help you understand that. You want to start up here with the serving size because it matters how much of the food they're talking about. There was a time when food manufacturers could make that serving size whatever they wanted, and that made things a little unfair. Like they would have a serving size of just a couple of little, hardly any of the food, and then they would list the nutritional facts, and no one was eating that amount. They might eat way, way more than that amount. So eventually they started regulating what they could call a serving, and it had to be reasonable to get away from that. All right, and then you want to check the calories, how many calories. And then these are the nutrients that you would want to limit in order to try to prevent chronic diseases for the most part is what you're trying to do by limiting those. You still need them. Remember, you still need fat. Fat's really important to a lot of processes in our body. We have to have some of that. We got to get those amino acids and from the protein down here. We got to get the fat. We got to get the carbohydrate, keep our, it's a fuel for our body. All of these are important, right? But these right here, you want to limit because people are getting way too much of them for the most part. Then you go down to fiber. People are usually getting too little of it, so you want more there. And then you want to get enough of these micronutrients, okay? And all of the micronutrients that you need, they all have an RDA, right? So you want to get, well, they all have an RDA or an AI. So you want to get enough of the micronutrients that you need. And then this footnote information, is present at times to tell you more. And the DV is like a quick guide. Can help you make decisions in a quick way. Oh, how much vitamin C is in this? Only 8% for the whole day? Calcium 20%. Oh, that's getting me closer. That's getting me closer to where I need to be. Iron. Oh, it's got a lot of iron, 45%. It can help you make decisions quickly like that. All right. Let's talk about energy. We get energy when we eat food. Without energy, we can't survive. That's just the truth. Types of energy, we have potential energy, that is stored energy or energy waiting to happen. And then we have kinetic energy, that's energy in motion. Those are two different types of energy. And we're going to talk about this kcal business that I mentioned earlier. About energy, the amount of energy in food is expressed in kilocalories or kcals. So people most often refer to kilocalories as calories. That's just how we refer to it in nutrition class and out in the world. Technically, that's incorrect, but to simplify things, we use the term calories. So how many calories do different nutrients have, measured in calories? We've talked about all of these already, but look at the variation of how many calories per gram they have. Protein has 4 calories per gram. Alcohol has 1 gram is 7 calories. Fat has 9 calories per gram. And then carbohydrate has 4 calories per gram. So you can see fat has the most, then alcohol, and then carbohydrate and protein have equal amounts per gram of calories. So the nutritional facts label can be used to keep people informed about how to reach their goals. And goals people might set could be, I'm going to eat more fiber. I'm going to get enough calcium. I'm going to eat less refined sugar. I'm going to eat fewer simple carbohydrates, which is a related goal. I'm going to eat enough calories. They may not be meeting their calorie needs. They need to eat more. Eat fewer calories, say if they want to lose weight and they have an obesity or overweight problem. So what is a healthy goal for each individual? That depends on their circumstances. That's why we want to talk about balance and we want to talk about being healthy whenever we talk about nutrition. People can get kind of obsessed with things and they can actually cause harm to their body if they try to do everything in excess, if they try to eat too few calories, if they try to eat too many calories, if they try to eliminate carbohydrates from their diet completely. You cannot do that in a healthy way. You must have carbohydrates to live. So people can set goals that are not very healthy. We want to always have healthy goals that are in line with recommendations. So total calories is estimating the number of calories in commercially prepared food is fairly easy since the total number of calories in a serving of a particular food is listed on the nutrition facts panel. So that can be pretty easy to do. If you wanted to know the number of calories in a breakfast you consumed this morning, then you have to add up all of the calories for each food that you ate to get that total. So applications for calorie counts. People who have been told to keep their calorie intake in a certain range for weight maintenance, weight loss, or weight gain can use calorie counting to do that. People who want to make sure they are getting the certain percentage of their calories from a specific nutrient, like keeping their saturated fat within a recommended range to decrease the risk of premature heart disease, can also do that. So you can add up what you're eating all day to try to see how you meet these goals. What if you want the calorie information from an unpackaged food? Well, you can go to something like Foodipedia, a website maintained by the USDA, to try to get that information. And it is available elsewhere as well. Like if you want to find out how much is in a whole apple, what's the nutritional information for a whole apple? That nutritional information is out there, and you can get that from places like Foodipedia. What if you want the calorie info for an unpackaged food? Continued. This information is also available from a wide variety of websites, books, apps on your phone. You can have an app on your phone that'll tell you this. Lists, it's widely available. Just make sure you're using a reliable source. But adding up those calories, let's say your breakfast calories were as follows. You ate yogurt with 150 calories. You put some granola on top of your yogurt, that's 209 calories. A glass of orange juice, about 100 calories. You have to have information about how big this glass of orange juice was to do that, right? Because orange juice comes out of a carton and you can measure the amount. So you would want to, accurately measure that and then figure out how many servings is in the glass you drank, and then put the correct number of calories when you add it up. So that's a total of 459 calories if you add those together. If this person is supposed to eat around 2,000 calories, they have about 1,541 calories left for the day after breakfast to eat. It's important not to get too fixated on the number of calories. Nutrition is about far more than that. Remember balance. Energy balance means the state in which the total energy intake equals the total energy needs. So what you're taking in needs to be equal to what you need. One measure of food quality is the amount of nutrients it contains relative to the amount of energy it provides. High quality foods are nutrient dense, meaning they contain lots of nutrients relative to the amount of calories they provide. And we talked about that the very first lecture. We talked about improving energy density, or sorry, improving nutrient density, not energy density, nutrient density. So does this food have a lot of nutrients for the amount of energy it provides? Because if you eat nutrient dense foods, you're more likely to be able to meet all your micronutrient needs. Otherwise, if you have a lot of junk foods in the diet food items that don't have any micronutrients, then you're not going to be able to get to that amount of micronutrient that you need for each day of all of those micronutrients. So, nutrient density versus empty calories. Here's another discussion of that. We've got nutrient dense calories. We've got calories that are low, nutrient value that's high, impact on health that's positive, value for your money is high. It helps to offset the cost of disease in society. Helps to do that, like keep healthcare costs down in general. And then empty calories. The calories are high, the nutritional value is low, the impact on health is negative, the value for your money is low, and it helps to offset the cost of disease. No, it doesn't. It increases the cost of disease in society and individuals. So what impacts how much food or energy we take in? Well, it can be a lot of things. We have physiology, genetic factors, behavioral factors, and social influence. So let's talk about physiology first. One influence of how much food energy we take in is our physiology. So physiology is scientific study have revealed that how much we eat and what we eat is controlled not only by our desires but also regulated by our physiology. We have a hypothalamus in our brain as a little part of our brain. There you can see it pointed out there. The hypothalamus in the brain is the main control point for appetite. The hypothalamus contains a distinct center of neural circuits that regulate hunger and satiety. So when the stomach is empty, the stomach contracts and the pang of hunger occurs. The growl from the stomach movements happen, and the neural signal is sent to the brain, specifically the hypothalamus. Other neural signals occur in other parts of the brain, and the stomach sends hormonal signals to the brain also, and we feel the need to eat. So when the stomach is full, the stomach stretches, the stomach sends neural signals to the brain, and these neural signals give a person a satiety feeling. The stomach sends hormonal signals to the brain too, and the overall message is to stop eating. Let's talk about the role of fat tissue, though. Fat tissue also plays a role in regulating food intake. Fat tissue produces the hormone leptin, which communicates to the satiety center in the hypothalamus that the body is in positive energy balance. So the hypothalamus senses nutrient levels in the blood as well. When they are low, the hunger center is stimulated, and when they are high, the satiety center is stimulated. What about things like cravings? Cravings are your body may really be trying to tell you something, okay? We joke around about cravings and say, oh, people are craving this or craving that. But there are times when a person is craving something like salty foods, and there's a physiological basis for that. They actually need to eat some salty foods, and their body is telling them, eat some salty foods. I need some salty foods. So be aware that it's possible when you crave something that your body is telling you it needs it. But it may also be possible that it's not a need and it's just something that's more behavioral. So we'll talk about those too. Then we have genetic factors. There's another influence on how much food or energy we take in. So genetic factors are very important, and twin studies and studies of adopted children who are twins is one place we get that information. So if you have two children that are twins or even siblings and are not raised by their biological parents but instead are raised by two different families, we have done studies with those that show that genetically related people have some similarities in their body weight and body fat amounts. So it's not that they're learning different, they're learning the same thing and therefore developing these similarities. They actually were raised by different people who had different lifestyles and they still had similar body weights or body fat amounts. So some of it is genetic. And here we have some twins. And there are, of course, identical twins and fraternal twins being more like siblings. But they're also raised at the same time in the same place. So you can get a lot of information when you study twins. But the best information, of course, is when you studied identical twins that are not raised together, which is pretty rare. But it happens. And when it happens, much can be learned from it about genetics. So genetics are complex. No one genetics or gene encodes for the factors that influence these matters, like what we eat, how satiated we feel. Um, there's not one gene. There's many genes involved in these factors. So a caveat is that genetics is such a complex issue. Genetics do not result in the exact same outcomes always, and we are not just our genes. So saying things like, well, I'm going to have this problem because I'm genetically just gonna have it. I can't do anything about it is really unrealistic because sure, you can inherit a genetic predisposition to many health problems or health issues or just all kinds of things, but that is not like a for sure definite that you're going to have this problem just because you have a genetic predisposition. Not necessarily. You may have a genetic predisposition for something like being obese, and then your behavior, your lifestyle, the food you are putting in your body, or all kinds of other factors can make a difference and actually cause you to not be obese, even though you were genetically predisposed to be. So next we're going to talk about behavioral factors. So third, influence on how much food or energy we take in. So a person's perception of good smelling and good tasting food influences what they eat and how much they eat. Their mood and emotions are also associated with their food intake. So here's just a few examples. How much food we put on our plates, that is a behavioral factor. The calorie density of the foods we snack on. So if we're snacking on potato chips versus, apple, then that's going to make a difference. How much we sit or how inactive we are. Are we sitting around watching TV a lot? We on our computer? We playing video games a lot? That's going to make a difference. That's our behavior making a difference. How much, or how long we chew our food can make a difference, because there's a certain amount of time that it takes our body to send all these signals and do all these things to make us feel satiated. So if we eat too fast, that actually hurts our ability to eat the right amount sometimes. That's pretty common in people. So slowing down for most individuals helps. That may not be true if your nutritional goals are to gain weight, but for people that have overweight or obesity issues, how much time they spend chewing can, if they extend that a little bit, that can help them to meet their goal of losing weight. And then how quickly we just overall eat, which is related to how long we chew. So if we chew a little longer, the length of time that we eat is longer. And then we have social influences. So there's a lot of social influences and a lot of change that's happened in the way people eat over the last century, but over time in general, and in recent times too. So what's been changing? Food portion sizes have been changing, and you see an example of a hamburger, like a fast food hamburger from 1955 until now. That's what they were selling. So in 1955, that hamburger is a lot smaller. Cooking versus home eating. So the pandemic kind of caused some shift in this, because we were eating out a lot more before the pandemic, and during the pandemic people learned to eat at home, and so people are home eating more. I don't know if that'll hold, but at least for right now people are eating at home more. Cooking techniques, food choices, different cultures and traditions even within the same region. Food industry trends, consumer choices, nutritional knowledge level, scientific information, and government regulation. All of this influences what people are eating. For example, if you take the example of government regulation, nutrition facts labels were not required at one time, and then they became required. Think about how that would have influenced what people ate, because now they could look quickly um, and see what was actually in the food nutritionally. And so that made a big difference. So all of these factors have made a huge difference. What impacts how much energy we expend or use? So this is the amount of energy we're using in our daily lives. What impacts that? Physiological factors and genetics, behavioral influences, and societal influences. Does this sound familiar? It's the same things that influences what we take in, right? Physiological factors and genetics. There is a theory that there's a set point for each individual in terms of energy balance. This is a theory. There's another theory that proposes a settling point, which takes into account the environment, the factors in society, the environment surrounding a person, like if there's a lot of inactivity in the environment that surrounds a person, and then genetic factors as a factor that takes into account what each individual responds differently to the circumstances in their environment based on their genetics. So an example would be sedentary and inactive lifestyle impacts energy expenditure. Absolutely. And then we have societal influences. Examples would be elevators, escalators, cars, sedentary jobs, high-stress jobs, and socioeconomic factors. So here's an example of socioeconomic factors. Obesity is inversely correlated to obesity in the U.S. So as socioeconomic status decreases, obesity increases. Why is that? Why is that? Because logically, you might think it's the other way, maybe. Some possible factors are less access to healthy food in some cases. So food deserts happen in this country where there are few food stores and only convenience stores located in some neighborhoods. And that's a big problem because what the convenience type stores offer is different. Less access to places to safely and effectively exercise. So if you can't exercise, then that decreases your ability to have a healthy lifestyle. Now, it's not that anyone's saying you can't exercise these places. Maybe it's not safe enough to be out on the street where you can walk a long distance or something like that. It can be a lot of things that are outside of the person's control. And then those things kind of become norms in the group, in the society, and more people are doing it. It's a societal factor, right? So access to cheap, unhealthy foods is available some places, and that cheap, unhealthy food, if it's what's available or what's only available because it's a food desert, then that's what they'll eat, right? Because that's what's available. And then people who have less resources sometimes have housing without cooking spaces. So they may be living in a room, they've rented a room from somebody, but there's no place to cook. And so then they're dependent upon getting food from outside their home that's already prepared. And we know that those foods generally aren't as healthy. It depends, but they're generally not as healthy. So here's a state map of the prevalence of obesity in the United States of America. And we have the 50 states here. We also have Puerto Rico on here. And you can see how things are in these different places. So you can see that when it's the darkest red, in those places, greater than 35% of the population is obese. So this is why we say there's an obesity epidemic, because you can see that a lot of states are the dark red or the orange. The orange is 30 to less than 35%, okay? So those orange places, 30 to 35% of the individuals are obese. And then we have the yellow. North Carolina falls in the yellow, where 25 to less than 30% are obese. And then green, we have 20 to less than 25%. And then a few places are less than 20% obese, like Hawaii and Colorado. So you can see that for most people, they're likely to fall into a category where they're overweight or obese. But we always want to keep in mind that there's others. There's other people that are right at the right amount. Their BMI, their weight, all of that is in a healthy range. And then we have individuals who are underweight, and we don't want to forget about them because they have unhealthy outcomes as well. And so we want to always remember balance, always remember individualizing the plan, and always remember that there's multiple different people. But as a whole, the United States has a big problem with increasing rates of obesity, and that has led to a lot of problems with our health that are preventable. And if we can help people make better choices, help them get a healthier lifestyle in public health, then we are going to help those people live better lives in terms of their life expectancy, in terms of how they feel, in terms of preventing chronic disease, which will give them a higher quality of life for longer. So that's what we're trying to do in nutrition class, is to learn about that, to learn about how the recommendations for nutrition and all of that influences us as individuals and then people we might encounter every day. And if you have an occupation someday that is impacting people's nutrition, then you can contribute to that. Even if you're not in public health, even if you're not in healthcare, there's things that you can do as an individual to improve your health and the health of those who you impact, to help the larger society become healthier, okay? So anyway, this is the map, and it's always changing. I can remember when, I think it was Mississippi was above 35, and that wasn't that long ago. So it's always changing, and improvements happen. And then sometimes people and as people have a decrease in their health, then so does all that add up to sometimes cause a statewide decrease in health. So there's times that people make those choices, and then states will move up or down in this map. But it's a good idea to look at this information and know what the real demographic data is saying about our society. All right. Please do your questions for this lecture, and then also if you're an online student, do your interactive discussion question. If you are an in-person student, I will see you in in-person class, and we'll see you in our next lecture, which will be Lecture F. Thanks.